Today's video is going to discuss the special cases that we will encounter during this factoring unit. There will be two special cases, and then we're going to look at factoring by grouping when you have a polynomial, not just a trinomial. So first off, we're going to talk about the difference of squares. And this is our first special case. When you have the difference of squares, you're going to have a squared minus b squared. This negative tells you the difference sign. So when you have this, the factors are going to be a plus b and a minus b. So an example when you would have the difference of squares would be, let's say we have m squared minus 100. You could see that the first term is squared, m is squared, and that 100 is 10 squared. So we can factor that to m plus 10, m minus 10. And then you're done. You don't even have to do anything else. Just notice that you have two terms being squared, and then you could factor it using that pattern. The next two are not as easily recognized. We have the perfect square trinomials. There's two of them, one with a positive and one with negative. So that's where you have a squared plus 2ab plus b squared. This is when they're both positive, and if you factor that, that is going to be a plus b squared. The reason that these are harder to notice is this middle term right here is going to be hard because you're going to have to see that it's 2 times what a is and b is. It's not going to be 2 times this number and this number because those are being squared. So a little bit different. And of course, the next one is going to be when we have a squared minus 2ab plus b squared, and that is factored to a minus b squared. Again, going to be a little bit harder to recognize. Two examples of these. Might look like this. So if we have 16y squared plus 24y plus 9, we can factor that to 4y plus 3 squared. So we get the 4y from this first term. Square root of 16 is 4. Square root of y is y squared. Is y. This term right here comes from the 9, the square root of 9. And then you would have to recognize where the 24 came from. So again, another example might look x squared minus 4x plus 4, and that would be x minus 2 squared. So again, these are hard to recognize. If you don't recognize these, it's okay because you can factor them the other ways that you know how. You can just look at this example and go, okay, factors of 4, 1 and 4, 2 and 2. Okay, well, I can do a negative 2 and a negative 2, so that would be x minus 2, x minus 2. And obviously, these two are equivalent. So either way, you can either memorize the pattern or you can factor it normal. But this one at the top, the difference of squares, you will see all the time, and you need to be able to recognize when to use that pattern. Okay, so let's look at a couple more examples. These are going to be a little bit more complex. Remember, we always GCF first. We're going to check for perfect squares, and then we're going to factor. First example, x squared minus 225. When it's a binomial like that, you should automatically think the difference of squares. So what I'm going to do is I'm going to factor this to x plus 15 and x minus 15, since 15 is the square root of 225. Another example using these special cases would be t squared plus 10t plus 25. So to factor this, I'm going to use the pattern for the perfect square trinomials, and that's going to be t plus 5 squared. Square root of t is t, square root of 25 is 5, and if you notice, 2 times 5 is 10 times t is where this 10t comes from. This is 2a, b, a is t, b is the square root of that, which is 5, so that's where you get that middle term. A couple more examples. Let's look if we have, let's see, 16 minus k squared. Same thing, just because you can't flip the k squared and the 16. It is not commutative. This property or subtraction is not commutative. It's a huge difference to say k squared minus 16. But that doesn't matter. You're still going they're still perfect squares. So the square root of 16, is 4 plus k, and then 4 minus k, and you're done. All right, got a couple more examples. Let's say we have 6y squared minus 24. Well, 6 isn't a perfect square, either is 24. So how are we going to factor this? Well, remember, the first thing we have to do, G, C, F first. I cannot say this enough times. So first, I'm going to take a 6 out of here, and I'm left with y squared minus 4. Well, I notice now I do have something that you still have to keep going. When you get to this point, you have to keep going. So this is the difference of perfect squares, so I'm going to bring my 6 down. That 6 cannot just disappear, and then it's going to be y plus 4, y minus 4. Now it is completely factored. Another example. Let's say we have 18 minus 2d squared. Again, I notice that I can factor a 2 out of this. So I'm going to pull the 2 out, and I'm left with 9 minus d squared. 9 and d squared are both perfect squares, so I can keep going. 2, 3 plus d, 3 minus d. All right, last example with this, and then I'm going to show you, let me show you 2 more examples, sorry. Okay, I know that I said, what number was I on? I'll say 6. If I have this, I can turn this around, right? I can move them. So x squared, even though I did say subtraction was commutative, but it is, so I lied. I'm sorry about that. You just have to make sure that you take the sign with you. So this negative 25 has to come with the 25. That is fine to do. You just can't put d squared over here and 16 over here. This sign has to stay with whatever that is. This is not allowed. This over here is allowed. So now that you switch the positions, you can factor this x plus 5 and x minus 5. All right, I want to show you one more example. All right, let's say I have, I'm trying to get organized over here. Okay, so let's say I have, who knows what number I'm on? 7. 4t to the third minus 144t. Okay, we definitely have to GCF this first. So I'm going to go ahead and pull out a 4, but if you notice, we have not done anything where we are factoring something that is a cubic degree. So I have to take a t out first. I can factor out a 4t, and then I'm left with t squared minus 36. Again, I can still keep going because t squared minus 36 is the difference of perfect squares. So I cannot lose my 4t. That has to stay with it. That is a factor. And then I could continue with this and do t plus 6 and then t minus 6. So again, the difference of perfect squares is a little bit easier to recognize and then factor. If you want to memorize the patterns of the other one, those work too, but you can always factor them how we've been factoring. All right, so next thing I want to talk about is when we factor by grouping. we're going to use this when you have 4 or more terms. 4 or more terms, and that's going to be a hint. Just like if you see a binomial, you should think, okay, difference of squares. When you see 4 or more, you can automatically think that you're going to be grouping. So we have x to the third plus 2x squared plus 3x plus 6. Okay, to do this grouping, you are going to group these first two terms together and then these last two terms together. You are then going to look at these first two terms and you are going to GCF what you can out of here. So if you notice, I can pull out an x squared because they both have two x's. So I'm going to pull out an x squared, and what do I have left inside? X plus 2. I'm going to do the same thing to this second group. I am going to GCF out a 3 and leave in an x plus 2. So now I am going to take these terms that I GCF'd, and I'm going to group them together. If you notice, this x plus 2 and this x plus 2 are the same. They have to be the same in order for this to work. So then I'm going to take these two and pull them out front as a group or as a factor, and then I'm going to leave x plus 2 here. The reason this works, because if you were to think, above here, I'm actually distributing this x2 to x plus 2 and this 3 to x plus 2. Well, I'm doing the same thing here. If I was to FOIL, I would take this x plus or x squared and go to both of these terms, just like I did up here. And then I would take the 3 and go to each term, just like I did over here. So it's just another way to factor when you have 4 terms. Let's look at another example. Okay. I'm just making up numbers that I'm on. I have no idea, so I'm sorry. Okay, so my first group is going to be right here. And my second group, I'm going to include that negative in there. So now I'm going to look at my first group and see what I can GCF. Well, I can take an x squared out of here. So I'm going to pull out an x squared, and I'm going to leave in an x minus 2. For this second group, I am going to GCF a negative 9 out of there. So I'm going to pull out a negative 9, and that leaves me with x minus 2. Remember, I'm taking a negative out of there, so I've got to make it negative again. Again, we need to make sure that what we have is the same thing, or this does not work. So what I'm going to do is I'm going to pull out, again, bring these down together, x squared minus 9, and then x minus 2, and those are my two factors. Let's do one more example with this. I have 3m to the third minus 15m squared minus 6m plus 30. So I'm going to group these first two together. And I'm going to group the second two together. Now I'm going to GCF out of my first group. I am going to pull out a 3, right, because I can take a 3 out of 3 and 15, and then m squared, and I'm left with m minus 5. And then on this one, I'm going to pull out that negative 6. I need to take that negative 6 out of there, and then I'm left with m minus 5. Again, this sign changes when I pull that negative out. All right, well, I'm going to bring down my 2 here together, 3m squared minus 6, and m minus 5. And I am done. All right, well, that's all for this video, and we will work more when I see you in class.